Now that we've shown that both the processing system Hello World and our Blinky Hello World projects both work, proving out both the processing system and the FPGA fabric, a common next step is to want to integrate those two things together. So the easiest way to do that is by creating a block diagram. I will call this PS Processing System and Blinky, and then I'll run my tickle script that creates my Zynq and gets this all formatted for me. Then the easiest way to bring a simple VHDL module into the block diagram is to simply drag and drop this in. There are instances where it won't let you do this and will force you to package a formal IP using Vivado's IP Integrator. But for now, this is a simple enough VHDL module that this will work just fine. And then we want to make these ports external, the clock and the LED. So just like we had created our ports, clock and LED in and out, we now have our clock on the left side for our input and then the LED on the right side for our output. But we need to get these symbols outside to the FPGA. And so in the block diagram, we have to right click on the port and say make external. We'll do that for both. Now you'll notice that the clock name here and the LED match our top ports from our module, which means that these names match our constraint file, but the IP integrator adds the _0 on these, which we do not want. We need these to match. Otherwise, the constraint files won't know how to allocate appropriately to these ports. So we have to go in and change these names. Again, we could change these names to anything we want. We would then just have to change the clock and the LED in the constraint file to match. But for ease of use and consistency, I'll just keep all this the same. We can regenerate the layout to make it a little bit more compact. We can validate our design. Everything is looking good so far. And then because once again, this is a .bd, we can't synthesize or implement this. And so we have to create our HDL wrapper. That updated, and you can see that now Vivado automatically assumed that we want this to be our new top module. And so you can still see our Blinky here, but if you drill down here, you can see that both the processing system IP and our Blinky behavioral module here have been instantiated inside of the block diagram. And so we can open this up, and this is all auto-generated. You shouldn't need to make any edits to this, but you can see that we once again have all of our processing system ports connecting to the IO and the DDR, but now we also have our clock and our LED. And these names were automatically pulled from these port names here. And so if we hadn't changed these names, then our wrapper would give names that no longer match the constraint file. That all looks good. We can go ahead and run through and generate the bitstream. All right, that was successful. So we can go ahead and open the implemented design, do a quick sanity check. All right, so now this is highlighted in orange, and so that gives us a good indication that the processing system has been implemented. And you can also look and double check that we have DDR and other IOs sent out of the device. And then over here, once again, you can come over here and look that looks like we have our counter set up and we have our IO pins for clock and the LED. So that all looks the way I'd expect it to. And now we can go ahead and open up our hardware manager just to test out the blinking LED. We can turn on our development board, open the target, auto connect, program our device, go ahead and say program, and our device is programmed and we have our blinking LED. All right, so that verifies the programmable logic blinking LED, but now we haven't done anything with the processing system to verify that that's working. We can come up here to our export hardware. We want to include the bitstream and that will work just fine. Finish that up. And then we'll head over to Vitis. We can actually go ahead and just keep using this Hello World workspace. This is going to be fine. So we can come over here to the Explorer pane, say new, and we're going to create a new platform because we have a new bitstream. So this one we'll call Blinky World. So now I want to come up here to our XSA and browse for it. So we can go back to our projects. We had put this one in the psmblinky.xsa there. We want a standalone, so it looks good. All right, so now we have our Blinky Hello World, and we can right click on this, and so we want a new application now. Since we had just created our platform, we can now choose our Blinky Hello World platform. So next, now we'll call this the same thing, Blinky Hello World application. We want it to be standalone, and we want our Hello World. So now we can come into our sources, open this up, add a new line, and then just add in another line so that we can say LED 0 should be blinking. Right, and that should be all we need to do. So now to build the project, we can come down here and on the system folder, we can right click and say build. And then on the debug that now has the green check mark on the hammer, we can run and launch on the hardware. This is saying that this has been previously launched, so we're going to terminate it before starting again. We bring up PuTTY. PuTTY comes up. If you flip back over to the hardware, you can see that the LED is blinking. And then this is just a formatting issue where I forgot to add in the carriage returns. So let's do that. You can use the PS reset button to do a full reset. Now we can see that this is out of date, so we can rebuild it, rerun. And now you can see a correctly formatted output on the UART.